Okay, so this is designed to manufacture digital tools for ME575. We're going to be focusing on the first unit of these material selection and focusing on primarily the nanomaterial selection for this presentation. So the research study was a framework for sustainable nanomaterial selection and design based on performance, hazard, and economic considerations. You can see the authors there, as well as the journal that it came from, which is the Nature Nanotechnology, the 13th volume, and it was published in 2018. So the specific scope of study was engineered nanomaterials emerging as high-performance replacements to conventional materials and chemicals for a wide range of applications. And then the key question addressed was really, could these E&Ms provide, practical and safe benefits or potentially result in environmental and human health implications or risks? So the methodology behind this framework was mainly based off of the Ashby Material Selection Index. And for this research article, they used an index with a slope of R sub FH with that ratio there, where LC sub 50 is defined as the concentration of a material that is lethal to 50% of a population. And the MIC stands for minimum inhibitory concentration. So the most desirable options that you would want out of this would to maximize that ratio as much as possible. So as like a viable substitute would be the zinc oxide nanoparticle, because it emerged with a low price and that high LC, which actually translated to a low hazard, and also a relatively low MIC, which translated to a high efficacy. So in this model, there was a life assessment of zebrafish toxicity, which was calculated where the most sustainable material is the one that requires the least amount of energy during production. And this life assessment was used to reflect human health impacts. You've got 4 different proposed nanomaterial substitutes. You've got silver nanoparticles, zinc oxide nanoparticles, and then single versus multi-walled carbon nanotubes. So the key result from study 1 is that we're focusing on E&Ms versus bulk chemical antimicrobial alternatives. And you've got, possible implications include price, that product designers were to pay to nanomaterial producers for the E&Ms and their product. You've got the cumulative energy demand, which is that CED. And the third consideration was, hazard to human health. And the least toxic material in that study was going to be the one with the highest LC50 value. Alright, so the key result from study 2 was comparing E&M-enabled composite materials for conductive polymers. Justifications for this included reducing those E&M release, providing stability, and enhancing functional performance. And specifically, for example, size, shape, and surface chemistry are all properties that can be partially or fully controlled through synthesis and post-fabrication approaches. And, they've all been shown, according to this article, to significantly influence E&M function and hazard profiles. So knowledge about these relationships can then provide tools and inform rational material design for improved functional performance, reduce adverse impacts, et cetera, et cetera. So if you look at this graph on the right side at the bottom, the B graph, it shows the nanoflake and the nanofiber. And you see it's aluminum oxide nanoparticles in 2 different shapes, and how that enhanced the polyaniline conductivity. And you see that the nanoflake has the highest conductivity with the lower CED, and then compared to the nanofiber, who has high conductivity as well as high CED. So in summary, for E&Ms to serve as a viable alternative to bulk chemicals or materials, they should exhibit the same or enhanced functional performance, while minimizing the potential adverse impacts. When comparing the E&M-enabled composite materials for conductive polymers, the E&M type and mass loading critically influence the net impact on conductivity. Price and cumulative energy demand also in the composite materials. And then my own personal critique on the research, as I think they did a good job with comparing the zebrafish toxicity life assessment, because obviously you want to know how this is going to affect human health and things like that. And I think they could do possibly a little bit, maybe a mammal study or something that would reflect more of the human health, and actually just doing like more in-depth experimentation for these alternatives. So, and that's it. Thank you very much.